All right, so we have officially started playing with the big kids now with our Surface View. What we are going to do in this next app over here is I am going to make some basic animation. I'm going to take my green dot that I had done in the previous view, and I'm going to send him in a sort of waterfall down the screen and just looping over and over again. And so the question is, how do we do this? There's going to be a lot that's same in the setup from previous apps in this series. So I have my main activity. In my main activity, I used a view pager 2 to load in a fragment. In that fragment, I had a custom fragment over here. I inflated my fragment main XML. My fragment main XML, which was in my layout file over here, included this custom view, and my custom view filled up the size of the parent, and it was centered inside of this parent over here, and the custom view is really where all the magic is going to take place. So we've got this green that's falling down. We have certain things like my holder and my surface listener. Something that we had seen previously in these custom views was using a method called like setup paint. And setup paint allowed us to initialize this paint over here, so I didn't have to do it when the surface was actually created. I can get my paint object. I'm going to use this paint object over and over again. So I made him a member of my custom view class. And I initialized him when I was ready to do that when this class, my surface view class, was actually created over here. So when my custom surface view class was actually created, I called setup paint and I initialized my mPaint over here. So he was going to be green. Then I grabbed the holder for my surface view, which is to say this entire space over here, who can respond to events like, hey, this holder is ready, this holder is getting destroyed, the size of this holder is being changed. I created a listener, and this is the guy who's going to be listening for all of the events to take place. I assigned my listener to my holder. So I'm going to listen for sizing events and so on and so forth. This class, I'm going to add a member canvas, and I'm also going to be adding a member, a float member, which is going to be the height of the canvas. And so when the surface was changed, or when the surface was actually created, ideally this should probably be above. I think I hit something I shouldn't have. So ideally we're going to want to just set this height up first. What I'm going to do is I'm going to make a new thread. And this thread is going to be responsible for the animations. And then I'm going to tell the thread to start. Now, threads get past runnables, right? So you expect to pass a runnable. And so the target runnable, I'm saying, is this. And this, in Java, means the current class. So this thread is expecting to be passed this current class over here, which says, hey, current class, you must implement runnable, right? So here's the runnable. Here's the implementation of runnable. And so if my class over here, my surface holder class, implements this runnable class, that's saying that this class has a method called run, which it does. So let's step through this guy right now from the beginning. Custom view gets called, the view gets created, I set up my paint object, I get the holder, which is going to be that sort of like the basic palette. I get the listener who can respond to events like, hey, it's time to draw, etc. And that's going to be in this class down here. When the when the holder is actually ready to be drawn upon, surface created is called. At this point, I get the height, I get the total height of this canvas, or of this surface view, excuse me. And I start a new thread, I create a new thread, and I pass it a class object, which implements runnable, which is to say this class, so that when this new thread starts off, it is going to run this run method in a background thread. So this run method over here. I'm going to turn him permanently true. This is running in a different thread. In my separate thread, I am getting the, while this is true, basically permanently, I'm getting the surface, and I'm locking the hardware canvas. I'm resetting, so this C.draw color resets the entire background to basically clear, which is black. And I'm drawing a circle at this Y position over here. So this Y position was initialized somewhere. Where did I initialize Y position? I don't know where I did it, but it was probably, it started off at 0. I should do a better job of cleaning that up. Anyway, I draw the circle, I increment him, and then I release the surface over here. So in this sort of moment over here, this canvas is being locked, drawn, release. Increment, lock, oops, that was wrong. Lock canvas, draw, release. Lock canvas, draw, release. And that's happening however many times per second. And I'm not doing anything more than what I need to while the canvas is locked. I'm doing all this incrementing stuff outside of it. So we don't have to worry about any additional computations because we don't want this system to become unresponsive over here. The position of our green dot moves down by 20 device pixels every single time this happens. And then if we reach the bottom, I loop us back up to the top of the device. And we just keep doing this over and over again. Now, there are some holes in this, obviously. I've got a canvas who is accessible inside of a thread over here. You know, you're definitely sort of setting yourself up for problems by not locking and releasing if you use this full time, but we can at least see the beginning workings of how to set up something to run in the background and to draw. And this is really going to be something that's a feature of these SurfaceView animations, right? You've got this separate thread and it's running and it's locking and unlocking. And this separate thread that's running has been set up in such a way that it's only called when the surface is ready, and the surface is only ready once you've initialized it and once you've created this custom view over here. So the next thing we're going to take a look at is controlling the frame rate, and then we're going to get into managing interaction with this this holder.